This has to do with SOHCAHTOA. Remember sine, cosine, and tangent. On your notes that you have printed up in front of you, I review sine, cosine, and tangent. Remember, these are ways that trig functions are set up. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. These are ratios, SOHCAHTOA. If you were in my class last year, I taught you some lame way to remember SOHCAHTOA. However your teacher taught you, these are the trig ratios. Now, I give you an example question. I say, all right, if you have a right triangle and this angle is 20 degrees, the angle of elevation is 20 degrees, this side is 10, and your hypotenuse is x. How can you find your hypotenuse? Well, you're going to have questions like this where you actually have word questions. I'm going to be giving you some word questions as well when you need to solve for this side. So this angle right here, let's say this is the ground level. This angle that it tilts up is called the angle of elevation, and that's 20 degrees. You have to find the hypotenuse on this. Last year, you were given word problems that had to do with trig, angle of elevation, angle of depreciation. Same thing for this lesson. You're going to be given some word problems as well where you have to create the triangle. But what I'm going to be walking you through is how to set up a trig equation and cross multiply to solve. So if you remember from last year, the angle that they give you is what you're going to write down. Now from this 20-degree angle, if I'm trying to solve for my x, this only works with, once again, just with right triangles. This angle is my adjacent, and this is my hypotenuse. So which one, sine, cosine, or tangent, has the O and the A in it? Well, when you look at these, cosine has the adjacent and hypotenuse, so that's the way you set it up. It's cosine of angle 20. You always put the trig function next to the angle equals your adjacent side over your hypotenuse, which is your x. Now, this is just a simple proportion. And remember, proportions, you cross multiply to solve. So x times cosine 20 equals 10 times 1. All right, so now with this, I'm going to get rid of some of this. And then once again, since this is pre-recorded, you can actually go back. If I lose you at any time, you could go back and re-watch it so it makes sense. All right, so look, I have to solve for x. Cosine 20 is some value, it's some 0 point something value. But anyways, how do I solve for x? I'm going to divide both sides by cosine of 20. Cosine of 20. So x equals 10 divided by whatever cosine of 20 is. Now, on your calculator, if you're not getting the answers that the book has, you have to make sure your calculator is in degrees. You do not want your screen to say radians. It needs to say degrees. This will not make any sense to you as to why right now, but when we start getting into radians, I think that second semester, you'll totally understand the difference between these two. Okay. If you have a graphing calculator, I think you press math or mode, then you go over 4 spaces to, I think you press math and you go down instead of degrees, it should be, instead of radians, it should be degrees highlighted, or maybe it's the mode button. If you don't have a graphing calculator, you're not getting the correct answers in the book, make sure your calculator is turned into degrees where it says DEG. You can even Google whatever kind of calculator you have. You can Google how do I make sure my calculator is in degrees and not radians, and just follow the steps. Just type in whatever calculator you have. Okay, so that was review with right triangles, SOHCAHTOA. Now I'm going to talk to you about exponential functions. Just touch base on exponential functions. Exponential functions is when something goes up significantly. Exponential functions could be, let's say this is a positive exponential function because it's increasing as x increases, y also increases. A negative exponential function would be something like this, where, well, I'll make it simple. An exponential function would be as x increases, the value of y decreases as it approaches each increasing on the x. An easy explanation would be, let's say, bacteria on a piece of food. And let's say this is days. This is day 1, day 2, day 3, day 4, day 5. As, let's say, like you open up a piece of bread in your cupboard. First day, second day, there's probably not a lot of bacteria. Let's look at the 4th or 5th day. Look how much more bacteria there is. And then let's look at day 10. Let's say day 10 is going to be way up here. It's going to increase exponentially. So by day 10, it looks like a stinking forest of bacteria. The amount of bacteria is a lot higher than it was at day 1 or day 2. This red is a negative. So think of it like this. This is called a growth. As the x gets larger, the y gets larger in value. This red is called a decay, meaning as the x gets larger, the y gets smaller in value. So let's say this is years. You buy a car. Let's just think about car depreciation. Depreciation for a car. Let's say you buy a car for $50K, $50,000. After the first year, let's say it's only worth, I don't know, $35K. After the second year, it's only worth $30K. After the third, after the fourth, after the, let's say, 5th year, look how much less it's worth. Which is true because cars depreciate, right, when you drive them off the lot. Let's say you buy a car and a couple weeks later you're like, oh man, this car sucks, I want to sell it. You can't sell it for what you sold it for, what you originally bought it for. Nobody's going to buy a car for $50,000 when you already owned it. Why would they? They could go to the dealership and buy the same exact car with it brand new. They're not going to buy your exact same car when you've already owned it. It's called depreciation. It decreases at an exponentially faster rate. So in the notes, I give you a formula for exponential functions. And the formula is called your initial amount. The amount that you have that's grown or decayed over time is your initial amount times your growth rate. Now, your initial amount for formula reason is called your principal, what you start with. Your growth rate, this is what the growth rate is. It's always 1 plus your interest rate percentage, or 1 minus your interest rate percentage. Let me explain this to you. Let's say you deposit $10 in a bank account. So the amount that you can figure out that you have is 10 times, this is the money, and let's say your interest rate, let's say it's growing at 0.25% a year. That means it's growing at 0.25% per year. So your growth rate is, you have 100% of what you deposited plus an additional 0.25%. So your growth rate is actually 100.25%. That's what your money is growing at every single year. So you would convert this into a decimal and put that here. What if your, let's look at the car, for example. The car growth rate, or technically it would be a decay. If you let's say you purchase a car, your starting amount, let's just keep these numbers the same, and let's say your principal amount that let's say you buy some crappy car for 10,000 bucks, but every year it's only worth 3% of what it was the year before. So your growth rate is whatever 100% of it minus your 3%. So what's your growth rate every year? If you look conceptually, if you think of this, you should understand that your growth rate is 97%. That means it's decreasing, it's a decay of 3%. Every single year, you need to figure out how much it is worth the year before. Now, this is called exponential function because see how in your notes there's a t. Your t is your time. So let's go with this car thing. Buy it for 10,000 bucks. I'll just put 10,000 bucks. And it's decreasing at a rate of 3% every year. So it's only worth 97% of its previous worth every single year. Times your time. This is your formula for your exponential function. The question would be, how much is it worth after 3 years? Well, you plug in a 3. 0.97 raised to the third times 10,000. And that tells you how much you have left. How much your amount, whatever it is worth after a certain amount of time. Okay, couple other things that I want to go over with you. One of those is imaginary numbers, and I don't think I really need to go over this too much. Imaginary numbers, you know I is equal to the square root of -1. I squared is equal to -1. The reason why is because I squared is this twice. Square root of -1 times this, not negative square root 1, times the square root of -1. I squared is going to equal, these roots cancel out to give you just -1. I to the third is equal to -I. I'll show you why. Because let's say we have square root of -1 times the square root of -1 times the square root of -1. That's I to the third. Square root of -1 times the square root of -1 is just these two cancel out to -1 times the square root of -1. I know it's kind of crazy, but if I've lost you, rewind it. So what is the square root of -1? Is I. -1 times I is -I. See how it's -I? I to the third's -I. And then check this out. I to the fourth is equal to a +1. The reason why is because, remember, I squared is equal to -1. Well, if you have I squared times I squared is -1 times another I squared, which is -1. I squared times times I squared equals I to the fourth, which is -1 times -1 is +1. Now, I to the fifth actually repeats. It goes in increments of 4. I to the fifth is the same thing as I to the first. It goes in increments. It goes I to the first, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10, 11, 12. Look, I to the fifth is equal to the square root of -1. Watch, let me show you. Remember I to the fourth was 1? What's 1 times I to the fifth? Or, I'm sorry, another I. This is I to the fourth times I equals I to the fifth, which is what I'm trying to find. 1 times the square root of -1 is square root of -1. Or you can simplify it as I to the sixth, 1, 2, 3, 4, 5, 6. I to the sixth is the square root of -1. Because, remember, I squared is -1. If you have 3 I squares, I squared times I squared times I squared, 2, 4, 6 equals I to the 6. I squared is -1 times -1 times -1. is going to give you positive 1 times a negative 1, which is a negative 1. It just repeats. It goes in increments of 4. It goes in increments of 4. So if I were to ask you, what's I to the 50th? What in the heck is I to the 50th? Well, you would divide 50 by 4, and then whatever your remainder is, you would figure out, you would count that over in your I. So I to the 50th, well, 50 divided into 4 gives me, what, 1, 4, 1, 0. So this is going to give me 12, 48 with a remainder of 2. That means it would go into it 12 times evenly with a remainder of 2. So you would have remainder of 1, which is equal to square root of negative 1. Remainder of 2, which is equal to negative 1. So what is I to the 50th? It's equal to negative 1. Okay, and then on some of the, on the example problems with I, just simplifying I give you a couple example problems. I want to look at 2, just the very last one. You can do the other ones if you want, but I want to look at the very last one. 2 minus I, and I'm going to change that where it says plus. I don't care about the plus. I want you to know how to multiply 2 minus I times 3 plus I. Let's say this was the example question. It's not, but let's just say it was. You would be multiplying 2 times 3 is 6, 2 times I is 2 times I. Negative I times 3 is negative 3I. Negative I times I is negative I squared. All right, and then if I combine my terms, I have 6 plus negative 1I, which is just negative I. I squared, whenever you have I squared, remember from last year, whenever you have I squared equals negative 1. These two negatives become a positive. 6 plus 1 is 7 minus I. So if you had this question that said simplify, your simplified answer would be 7 minus I. Sorry if I went through that a little fast, but if I did, go ahead and rewind it to see where I lost you. Okay, the very last thing I want to talk to you about is, and you're going to be setting these up a lot next semester, 30, 60, 90-degree triangles. Now the way a 30, 60, 90-degree triangle is set up is, your shortest leg is always half the size of your hypotenuse. And your medium leg is your short leg times root 3. It's not a formula, it's just a pattern. If you were in my class last year, this should look super familiar to you. Now, let's say this side was, let's say in a 30, 60, 90. Let's say this side was 8. That means your hypotenuse is half of that, which is 4. Your middle leg is 4 root 3. The Pythagorean theorem would work for this. If you were to do a squared plus b squared equals c squared, it would work. If you don't believe me, go ahead and try it. But more importantly, what you're going to have is this. What if I were to say, what if your hypotenuse is a 1? Find the other two sides. Well, this side would be half of that, which is 1/2. This side would be half of that times a root 3. Instead of 1/2 times root 3, you would just say root 3 over 2. That's the same thing. You're going to see this pattern all the time come next semester with 30, 60, 90-degree triangles. Now the book might also ask you about 45 or reviewing. Remember, this was taught last year in math too. It might ask you about reviewing right triangles. And the way right triangles work, the simple, this is x, this is x, this is x root 2. So let's say this side was 1, this side was 1, this side would be 1 times root 2. But what if I were to give you this? What if I were to say in a 45, 45, 90, your hypotenuse is 1/2. I'm sorry, not 1/2. Your hypotenuse is 1. What would both of these sides be? Well, you would have to work backwards. Instead of setting this as x root 2 equals 1, you can work backwards and say, okay, this side, if this is always x and x root 2, I would have to divide both sides by root 2 to figure out what these sides are. You would have to set it up, because this side is normally x root 2 equals x. Because this side normally is x, this is x root 2. But now I'm telling you, this side, which is normally x root 2, is actually equal to 1. Normally this is x root 2, but now I'm telling you it's equal to 1. How would you solve for what both of these x's were? Mathematically, this is what you would do. You divide both sides by root 2 to get x, this side, equals 1 over root 2, but you can't have a square in your denominator, so remember you have to multiply the top and the bottom by root 2. This cancels out to give you 1 times root 2 is root 2. Root 2 times root 2 is 2. So x would equal root 2 over 2. If I lost you on that, because I kind of went kind of fast, if I lost you, just remember this pattern. Whenever you have a 1 as your hypotenuse in a 45, 45, 90, just know your other two sides, because this is an isosceles right triangle, that's what makes it 45, 45, 90, because these two sides are the same. If your hypotenuse is 1, this is root 2 over 2. Technically, this is 1/2 root 2, 1/2 root 2, or root 2 over 2. All right, so your assignments are at the very bottom of this page.